All right, so first let's talk about what makes a parallelogram special. First things first, the top and the bottom are parallel, and the left and the right are parallel. That's why it's called a parallelogram. The top and the bottom are also congruent. The left and the right are also congruent. The opposite angles are congruent, and they are supplementary to each other. The adjacent angles are supplementary to each other. And the diagonals, these lines here, they get bisected. All right, so that makes a parallelogram. Now, what is enough to prove that something is a parallelogram? One, let's work with the angles first, okay? So if you can show that the adjacent angles are supplementary to each other, then that is enough to prove that these are parallelogram. Okay, they're a parallelogram. Not just one, it would have to be two adjacent angles. Okay, this one. This is enough to prove it's a parallelogram. If that angle is congruent to that one, and that angle is congruent to that one, it is a parallelogram. Diagonal angles, the opposite angles are congruent to each other. Now this one, if the top and the bottom are parallel and equal length, it is a parallelogram. If the diagonals bisect each other, it is a parallelogram. Okay, but it has to be, these are the minimums. Both of these have to be congruent, minimum. Supplementary, supplementary. Two adjacent angles right next to each other have to be supplementary, minimum. Parallel and congruent, the minimum. Both have to be bisected, the minimum. This one, if the top is parallel to the bottom or the left is parallel to the right, they would have to be both to be a parallelogram. The top is congruent to the bottom and the left is congruent to the right. That is also a parallelogram. Now, let's do some Pythagorean theorems. So Pythagorean theorem is a squared plus b squared equals c squared. Now, c squared is the most important one. Whatever is in the hypotenuse, the longest side of the right triangle, is going to be in c. If you have an issue finding the hypotenuse, the 90-degree angle is pointing at it. Like that. All right, so we know that this is the hypotenuse. So this is 5 squared plus 12 squared. So this is 25 plus 144 equals x squared. If you add these together, you're going to get 169 equals x squared. The final step is square root both sides, and you're going to get 13 equals x. Okay, so that actually has a solution. Now this one. So a squared plus b squared equals c squared. 15 is in the hypotenuse, so 15 has to go here. The rest of them do not matter where they go as long as they're in the formula. Now, x squared goes here, plus 9 equals 225. You're going to subtract 9 from both. X squared equals, we're going to subtract from here. We're going to borrow, do a little borrowing action. You're going to have a 6, 1, and a 2. So 216. Square root both sides. So square root of 216 is my final answer. That's horribly written. I don't know why I'm going so fast. But the final step is going to be square root of every single problem. Now this one just had a solution. So let's see this one. So again, a squared plus b squared equals c squared. C is the only important one. In this situation, it's x. The other two do not matter where they go. All right, so 5 squared is 25. The square root of 11 squared, these cancel and it just becomes 11. So it's actually pretty easy. Then combine like terms and we get 36 equals x squared. We're going to square root, the final step, 6 equals x, and we are done. Now let's do this one. So 6 is going to be c because it's in the hypotenuse. Put this 90-degree angle there. So 6 squared equals x squared, 2 square root of 5 squared. So everything in here gets squared. The 2 gets squared, and the 5 is getting squared. So you're going to have a 4, and you're going to be multiplying with, canceled, 5. So 4 times 5 is 20, plus x squared equals 36. Subtract on both sides, x squared equals 16, square root, x equals 4. And that's it.